Hi folks, Mrs. Fate here again. Here we go, lesson number 5 in our P1 energy topic, changes in energy stores. Now in year 7 you will have looked at the way that we store energy in different places, and you would have looked at what those energy stores were. What we really want to secure now is describing the way that energy is moved from one place to another when a system changes. So there's some key terms in here that we'll come back to in a little while. First of all, let's just recap something that's really important in terms of how science works words. So our purple zone today has got an anomalous result in. So an anomalous result is a result that doesn't seem to fit in with the rest of your data. It doesn't fit the pattern. A very simple experiment here where we take a spring and we put a mass on the end, and we've got a ruler here to measure how much longer the spring gets when you put different masses on here, recorded here as the weight of that mass in Newton. So if an anomalous result doesn't fit with the pattern, have a look at the results and see if you can identify which result doesn't fit the pattern. So answer questions numbers 1, 2 and 3 and pause the video while you do that. Okay, so the result here for 0.5 newtons says 23 centimetres. That was the average length of the stretched spring, but it doesn't seem to fit in with the pattern before, 6.2. And then if we ignore this one, we have 13.5, 17.6. So they're all increasing, but this one is a little bit odd. It stands out as odd. So if you noticed it while you were doing the experiment, what you would do about it would be you wouldn't include it in your data analysis, and you would repeat the result if possible. You'd do that one again. If you had enough data, if you repeated the experiment 3 times, you wouldn't put that data into the mean because it obviously doesn't fit the pattern. Okay, right, that's a quick recap on how science works words. So back to our changes in energy stores. Now this is a great demo. It's good on the YouTube as well. So if you've got access to the PowerPoint itself, you can pause this video now, click on the link and watch that custard powder demo because it's a great one. Just thinking about what energy store did the custard have at the beginning and what energy store would have been reduced by the end. So in terms of changes to energy stores, if we can identify different energy stores and identify simple changes, then we will be looking at a level 4-5. Further up, describing changes in energy stores in terms of the process, we call that a pathway a bit later on. That would be about level 6 work, and more than that we would be able to explain factors that affect the size of changes in energy stores. So when we're talking about energy, it's a rather difficult word to sort of quantify, if you like, to explain what it means. So what we say is that basically energy makes things happen. We can often calculate different types of energy stores. Okay, so energy stores are places, locations where energy can be said to be stored, and we've got some examples here, but we'll go through them in a minute. Now, as I said, you've done some of this in year 7. That'll be a really good place now to recap. Click on the link in the original PowerPoint. No point going beyond 3 minutes 50 on this one. Okay, but look at the 8 stores of energy and then think about how energy is transferred from one store to another. If you're in school and you've got access to the card sort, you can have a go at that, but otherwise grab one of these pieces of paper, one of these sheets. Okay, should be available for the lesson, and you've got either ones with the energy stores written down and you write down the description, or a slightly easier version where you've got the description written down and you just identify the energy stores. So the energy stores that we are just revising from previous years are these. So you need to pause the video and make sure you've got these down. Okay, so I'm not going to go through all of them, but just give you an example. For example, kinetic or movement store of energy is energy associated usually with a moving object, although later on we can talk about that in terms of gas molecules or atoms moving in a later topic. Okay, so there you've got 4 of them. Let's look at the next 4. We'll cover these calculating gravitational potential energy stores later on in a further lesson, future lesson. Okay, so we've got electrostatic, gravitational potential. That's due to, basically, an easier way of saying that is the height above the ground. So something that's got mass and is inside a gravitational field. Elastic potential energy, to do with objects being compressed or extended. Okay, so you fill those in, and then we'll move on to looking at how we get changes between different energy stores. Okay, so this is a no slide, so you need to pause the video and write this information down. It's talking about an energy pathway. So when a system changes, and by system we just mean either a single object or a group of objects. So when a system changes, energy can be transferred into or away from the system you're studying, so long as it's not closed, between different objects in the system, or between different types of energy stores. So the 4 pathways we're going to look at, and do need to make notes on these as well, are mechanical pathways. So when an object is accelerating or is deforming due to a force acting on it. Work done by moving charges is an electrical pathway, electrical current. If you heat an object, then energy is transferred from the hotter to a cooler object, okay, when left to cool. And then by radiation, so objects can emit or absorb radiation. So we're going to do a practice now. Now the sheet you had earlier that looked like this one, there's a second page to it, and it's got some notes on about the energy pathways, and it's also got this on here. So this is a bit of application. So we're looking for 3 energy stores here and 3 energy pathways. So think about a battery. In year 7 and 8, what did we say was the energy store inside a battery? Same one as is inside food or a fuel, for example. Okay, so let's have a look at the energy stores here. So we've got our chemical store within the battery, our gravitational potential store here, because we've got a motor and that has raised something up. So if it's higher, it's got a bigger gravitational potential energy store. And in the environment here, if this motor is working, if you've ever been next to a motor that's working, you'll realise it increases the temperature of the surrounding air. So we've increased the thermal store of the environment. Okay, so what are the 3 pathways then? We've only got those 4 to choose from that we looked at earlier. Okay, so from our chemical energy store in the battery to our motor, we've got an electrical current. So that's pathway number 1. To raise the load higher, we've got a mechanical store, and then down here we've got mechanical due to friction, and then by heating, increasing the thermal energy store of the environment. Okay, now another bit of application really, just identifying the words, and I think I've put the initial letter of the words on the sheet to help you. I'm only going to show you a couple of examples because then you can fill in the sheets and we'll go through the answers. These are looking at energy stores and energy pathways for a few specific examples. So this is the first one. If you throw a ball upwards just after the ball leaves your hand, remember this is a sheet you can fill in, okay, it has energy in its watt store. So these are one of the 8 stores that you have looked at earlier when you completed the table of energy stores. So what word are we after there? Okay, so if it's moving, it's kinetic. So this is energy in its kinetic store. When the ball's reached the highest point, it's got its biggest store of gravitational potential energy. You getting the hang of this? And then just before you catch it again, gravitational potential energy has been transferred to its store of kinetic energy again. Okay, so here's the second sheet. And I think what we'll do is we'll go straight to the answers. So you have a go at filling in the rest of the sheet. Okay, get your green pens ready, and then you can self-assess. Now I'm going to whiz through these fairly quickly because of course you can pause the video whilst you're watching this. So that's the one we've just been through. There's our boiling water in a kettle. Burning coal. Remember, pause the video as and when you need. A car using its brakes to slow down. Oh, they're very fond of this one in the exams, by the way, so have a look at this. Here's a new word, dissipated. So this is when kinetic energy has been transferred to a store of thermal energy which is then transferred or dissipated, means wasted really, to the surroundings. Here's our magnetic one. Okay. All right, so you've been pausing the video as you go along. Now this is an excellent little website called PHET, and you can pause the video, go to the other PowerPoint, and then you can click on this and you can run this. Now there are a couple of sheets for you to fill in as well, so if you get the opportunity, that is well worth doing. If you're doing this from home, I thoroughly recommend you have a go at that one. Okay. Right. Meanwhile, let's just have a look at a very basic foundation question here. The diagram below shows a cyclist riding along a flat road. As the cyclist accelerates, what energy store in the cyclist's body decreases, and what energy store increases? Okay, so they're accelerating. That means getting faster. So, chemical energy store in the cyclist's body, and the kinetic, because he's going faster. Okay, so that kinetic energy store is going to be increasing. Okay. All right, now I'm going to skip that question there. I'm going to go straight to this one. Okay, so here is looking at different energy stores just to remind ourselves, can we identify them? And then for an extension, what are the 4 energy pathways? Okay, so here we're talking about the energy stores, and then what are the energy pathways? Pause the video, have a go at this one. Okay, so just simple identification then. We've got thermal energy, gravitational potential, elastic, magnetic, chemical, electrostatic, nuclear, and kinetic. Okay, now did we get the 4 pathways? We wrote about these earlier. So mechanically, moving something, we've got heating by an electrical current, and then radiating away. So heat and sound both radiate away from things. Now there are some worksheets to go with this lesson, so I suggest you have a go at those, practice, and aim high, guys. Okay, well done. Thank you for listening.